This is a puzzle called X Door Neighbor, then cul-de-sac by Kuraban. I got it from the Sudoku Testing Submissions channel on the CTC Community Discord. Let's take a look at the rules. X Door Neighbor rules apply. I think this is maybe their own creation, or maybe I just haven't seen it before. This variant, I mean. The clue outside the grid gives a total of the first X cells in that row or column, where X is one of the adjacent cells in that row or column. Okay, so example here, thank you. So the 7 clue at the top of column 2. So for the 7 clue, the X value is either, okay, so it's X sums, but the clue for column 6 must come from here. Okay, so it's X sums, but the X is not in the column. Yeah, so X sums, if you haven't heard of X sums, it works sort of like this, where this 7 clue would mean the first X digits of this column sum up to 7, where X is this digit. So if we found that this digit was a 2, actually this 7 is actually very restricted in X sums. So if we found this was a 2, then that would mean these 2 cells add together to be 7. If we found this was a 3, then these 3 cells would add up to be a 7. Now, with this, the X is next door. So one of these will be the thing that determines how long this is. And it could even be a 1. 1 in X sums is just always a 1, but it could be a 1. Like this could be, I think this could be a 1, and this could be a 5. Yeah, I think that could work. Okay, so I think that's the rules. I'll put a link to the puzzle down in the description if you want to give it a try yourself. Let's give it a go. So maybe this is the place to start. They said it's always next to it, and since this only has one adjacent thing, it even says it specifically. This is the X for this. So I think it could be a 2 actually. It could be 2 and then 4, 6. It could be 3 and various options, or it could be 4 and 1, 2, 3, 4. Okay, so that's not helpful. Apologies if you can hear my chair. It's a very squeaky chair. Okay, so for this column, I think it's important to realize that for a full column in a 6x6 puzzle, the value is, or the total of all the digits in one column is 21, because each column, row, and 3x2 box has the digits 1 through 6, which sum up to 21. So this full column is going to be 21. Now we need to take 7 away from the top. So some amount at the top is going to be 7. And then some amount at the bottom, which theoretically, at least at first glance, could be something like this. Let's just get rid of the greens for a second. So it could be theoretically something like this, but the important thing, I think, is that 7 is not a valid one-cell digit. So we have 7 down here, which must be at least 2 digits. We have 7 up here, which must be at least 2 digits. And then we have some unshaded amount in the middle. And I think that must also be 2 digits, because we can't type a 7 in here. The most we can do is 6, and 7 plus 7 plus 6 would be 20. So there must be, these must be, whoops, come on. These must be pairs, which means we're going to need a 2 in one of these spots and a 2 in one of these spots, which we're going to then have an X-wing on 2s, which let's just get rid of this. Let's explain what an X-wing is. So in one of these spots, in row 1 and one of the spots in row 6, there's going to be a 2. So once we finish the puzzle, it's either going to be a 2 here and a 2 here, or a 2 here and a 2 here. Those are the only 2 options. And you can kind of see this, that would make an X if you drew a line from each corner to the middle. That's where the name comes from, I believe. Now what does that accomplish? That means we can never have a 2 in any of these gray cells. If we tried to put a 2 in here, neither of these would be 2. So in row 1, we'd have to put a 2 over here, and in row 6, we'd have to put a 2 here, which of course that's 2 2 2's in column 3. Breaks the puzzle. So we can't have a 2 in any of these gray spots, which means in box 3, where can a 2 go? It must go in the middle. It needs to add up to 7 total, so this is a 2, 5. So this is a 3, 4, 1. One of these is 3, 4. One of these is 1, 6. We don't know which is which. Okay, that means this isn't a 2. So this 10 over here could be 3, could be 4. Okay, maybe this 11 clue can give us something, because we have this. So what could this be? Normally it could be 2, 3, or 4. Because it could be 6, 5, or it could be a 5, 6 pair normally. Obviously that won't quite work in this situation, but normally this could be a 2, 5, 6. We've already used the 2 in this box. Whoops, so this can't be a 2. So this is a 3 or a 4. Oh, and we can kind of do the same trick as we did with these 7s. There's some amount here. Yeah, there's some amount here that's gonna be 11, and we don't know about this cell, but it's either this or it's either this or this. And the 5 coming from the right is going to be at least one cell, but it could be 2 cells. It could be like a 3, 4, or sorry, 3, 4, 3, 2 pair. But we're gonna need some space in between. What does that add up to? 11 plus 5 is 16, so we have 5 left over. Okay, so what does that mean? We need at least one cell open in the middle, but we could have both cells open. Could we actually have both cells open? Let me look at that. If this was like this would be a 5. There'd be a 1 somewhere over here. Oh, you know what? I'm dumb, actually. Let's back up. A lot of that logic is good, but I said this had to be 2, 3, or 4, but that's not true. The 2 could... One of these is this guy's. We don't know which one it is. It still could never be a 2, but okay, so yeah. We were coincidentally mostly right on this. This is not necessarily the cell. It's one of these 2 is the cell that gives this. And we'll have to figure out what that cell is, but that's going to be a later step, I guess. The logic of the row needing a space is still going to be true. So one or both of these cells are empty. If these were both empty, this would be a 5, because it has to add up. Just one cell has to add up to the full thing. There's going to be a 1 somewhere. Then this has to add up to 9, which could be 3, 6, and this would be 1, 4. That seems to work just fine. There's only one way to make 11 in 4 digits, which is 1, 2, 3, 5. Oh, that's the key. That's the key. Where do we put a 6? That's the key. If this was part of green, where do we put a 6 in this puzzle? This must be empty because we need a space. We need at least one space. Well, I guess there's multiple ways to look at this. This must be 1, 2, 3, 5. But this also has to be a 5, so the puzzle breaks. But the way that I looked at it was, where can I put a 6? 6 is not in here. It can't be in the space, and it can't be in here because it breaks that segment. Whichever segment it's in, it breaks. So this can't be 4 cells. So this is 3 cells long. One of these is a 3. I don't like pencil marking that, I don't think. I think I'll just remember that green is 3. I mean, obviously there's 3 cells there, so hopefully that's not too hard to remember. Now this is a 1 or a 2. If this was too long... What am I doing? If this was too long... That's literally the opposite of what I meant to do. If this is too long, this is a 5. This is a 2, this is a 5. This has to add up to... Yeah, okay, so that's the thing. So that's something I see. So if this is too long, then this has to add up to 5. If this is 1 long, this adds up to 5. So 5 is in one of these 2 cells, no matter what, which makes this a 2 and this a 5. Which means this has to be 3, 6. And this is 1, 4. And then this row is 1, 4, 5. The 1, 4 will be the pair that adds up to 5, and the 5 will be the single cell that adds up to 5. And then one of these will be a 2 or a 3. Sorry, a 1 or a 2. So if it's a 1, it has to be up here. And if it's a 2, it could be either one, I think. Okay, but what I see here, this needs a 3 next to it to differentiate, or to indicate the length of the box. So this must be the 3, because if this was a 3, the puzzle's broken. So this is a 3. That's going to differentiate that, disambiguate that, and then also give us this, which is nice. So this is 2, 4, 5 left in the box. 2, 4, 5. I don't know if that's helpful. 6 must be over here because it's looking over. 3. No, we're good on 3s. What about this? This is 6, 2, 4, 6, 2, 6, 2, 3. I'm literally trying to read the digits here, and my brain just says the wrong digit. Okay. Okay. I think we need to find another clue to examine. We've done this clue as much as we can. We've totally finished this clue. Let's color that. Yeah, we need another clue. Can we do anything with the 7? The 7 is either a 2 cell or a 3 cell. Let's make it pink. So it's either a 2 cell or a 3 cell, but either of these could be 2 or this could be 2 or 3. This could be a 3. So we have a decent number of options. If it is 3 cells, that would be 1, 2, 4. That doesn't seem to break anything. I was thinking maybe it would cause some contradiction, but I don't see that it does. If it's 2, then it could literally be any digits, because they just match up like that. Okay, so what about 10? If this was if this was 4 long, let's make it dark green. But these colors are going to get out of hand pretty quickly. Maybe I should remove some of it. I mean, removing this doesn't make it less out of hand. Yeah, we'll just think about it. So if this is 3 or 4 long. If it's 4 long, this must be a 2 or a 3. This must be a 1 or a 4. Actually, if it's 4 long, this must be a 4. Then this must be a 4. Which makes this a 1, 2, 3 triple. So then these would be 5, 6, which would force this to be 2. Too long, because 5, 6 is too large. Hmm. 4 would also put a 4 there, 4 there. What did I say? 4 there, 4 there, which then... Not a super helpful set of 4s there. If this is a 3, we don't really get that much information, I don't think. These 3 would add up to 11, because these 3 add up to 10, and we need to fill up the whole column. I'm thinking to myself. Yeah, that's one thing that's hard with videos. Like, if I don't want to put my face up there. There's no... I don't think that adds anything like the same way it does for Simon and Mark or any other YouTuber. So when I just go silent, it's like, did I just stop talking? Did the video stop? What's going on? Okay, maybe we need to look at this 9. So 9 is either 2 or 3 long. Let's use... let's change this to be light blue, and we can have this be dark green. So if this is too long, this needs to be 4, 5 or 3, 6. There's a lot of... So if this is too long, this is 3, 6, which makes this a 4, makes this a 1. If this is too long, this is 3, 6, makes this a 4, makes this a 1, or 4, 5, which makes this a 1. So if this is too long, this is always a 1. For whatever that's worth. I mean, getting a digit is always nice, but does that make things hard? If this is a 1, no, I guess we already have this cell open too, never mind. I was thinking adding up to 12 when we force a 1 and this digit isn't necessarily very large. But we have this 4th digit down here. Yeah. If this is... Oh no! Okay, so this can't be 2. That's the easiest thing to look at. We already have 2 in the row, so we can't have the X-door neighbor dictating that it's a 2, so it must be a 3. Which means this is n, which means for this to be a 6, that would require a 1, 2 like this. Okay, here's the thing. Okay. So we have a triple that adds to 9. It must have a 1 in it, because if it didn't have a 1, whoops, if it didn't have a 1, what am I doing? If this didn't have a 1, this is 2, 3, 4, which breaks this cell. So it must have a 1 in it. So 1, and it can't be there. So one of these is a 1, this is a 4, which makes this a 3, not a 3. Which actually makes this a 1, 2, 6. This can't be a 2. Yeah, so this is a 4. These can't be 4s. That makes this 3 long. Okay, we're making progress. This must be a 5. It's the last digit left in the column. Yeah, so this is a 5, so this is a 4. This is a 2, 5. No, that's not a 2, 5. What am I talking about? One of these is a 2. There's literally a 5 there. I don't know. My brain doesn't like that sometimes. One of these is a 4. Then we have a 1, 6 to finish off the area. Okay, so if this was if this was a 1, this has to add up to 9 to make 10. And it can't be 3, 6, and it can't be 4, 5. Therefore, this is the 5. This is the 1. So this is just yellow. So it needs a 2 in one of these spots, which seems reasonable. At least I don't see why either of them would immediately break. Why did I make this light green? I think I might have misclicked at some point. I don't know why that's light green. I don't know. I think this was light green, and then I changed the color. Yeah, maybe not. I don't know. So this has add to 5, and it can't be 3, 2. So this must be 4, 1. So this must be 2. This must be 6. Then this is... I don't know. That's helpful. I was gonna say this is 2, 3, 6. Whoop, 2, 3, 6. This can't be a 3 though, and this can't be a 2. Maybe it's more helpful than I thought. This could still be 2, 1, 4. I think. Oh, this can't be a 2, so one of these is a 2. So if this is 2 cells long, this is 6, 1, and this is 2. If this is 2 cells long, this must be 6, 1, because that's the only pair that works. And this is a 2. If it's 3 cells long, this must be 2, 1, 4. So either way, this is always a 1, which makes this a 6, this a 2. Which means this can't be a 2. So this can't be 2 cells long, so this must be like this. Whoops, wrong way. But now... Oh, we have a 6 up here, so this is 3, 6, 3. So this 3 goes with that. And with green, both. This goes with light blue. We don't know which is dark blue, and we don't know which is dark pink. What's left in this column is a 5. This 4... Whoops, sorry. This 4, disambiguates that. So this is a 5, 6 pair. This must be the 6, which now the 5 figures that out. On this 4, I guess I probably a while ago figured that out. So what's left is a 2. So this is part of dark blue. This is part of dark pink. Oh, and this is part of yellow. I didn't mark that. I didn't actually remember that, so that's good that that actually worked out. That means I have the right... that means I have the right solution. Because I forgot about the 1, forcing this to be 1 long. But this, let's just double check. This adds to 7, and we have a 2 next to it. This adds to 11. This has a 3 next to it. 7 with a 2, 9 with a 3, 7 with a 3, 5 with a 1, 10 with a 3. Yeah, I think that's right. That was a lot of fun. That that definitely kind of warped my mind a little bit. Uh, yeah, that was a tough variant. Just given the possibilities. Yeah, with X sums, with like pure X sums as opposed to X door neighbors, the options are really restricted, since the digit that defines how long it is also used in the sum. Like it just rules out a lot of options, a lot more than you would think. Just thinking about it, just briefly, it's actually a very restrictive thing. Um, but yeah, with next door neighbor sums or like reverse X sums, which is when n defines the length of the on the opposite side, uh, it's uh, it can be tough. This was not an easy puzzle. Probably like a 2 out of 5 difficulty, I think. Uh, but if you tried to make this like a 9 by 9, I think that would be an extremely difficult puzzle. But that was a lot of fun. I really enjoyed that. Thank you, Kuraban, for that puzzle. Uh, and thank you all for watching.